Welcome back. We're still on Unit 1. We're doing programming paradigms. So let me just start straight away. What are programming paradigms? So the use of standard structures and conventions to build and develop accurate, efficient, and effective computer code to fulfill identified criteria and solve problems. In other words, writing good computer code by using common coding practices to solve problems efficiently and obviously correctly. Handling data within a program. What does handling data within a program actually mean? It would be, I would label this as using data types, data structures. On page 22 of the specification, there is a full list. I will focus on the main data types and a few data structures. So I won't be going through every single thing, but I should go through enough to give you a good understanding. So we have primitive data types. These are the most basic ones. So the primitive data types that I'm going to be focusing on are the ones for Python 3. And again, we have integers, which are whole numbers. We have doubles or floats, which have a decimal point. I think floats is what Python uses most. A double has double the precision of a float. So for example, in a float, let's say we have age, right? AGE. I don't know why I chose age. And we can have up to, I think it's 64 numbers. However, with a double, what this allows us to do is have 128 instead. So Booleans have a true or false value. Now we can force this to be something else. So it can be true or false, yes or no, up or down, but typically speaking, it's true or false. Chars or strings. So these are simply characters or strings or alphanumeric characters. That sounds a bit off, but what does this actually mean? Once you put something in quotes, that makes it a char or a string. Integers, doubles, and booleans do not need to be in quotes, but once you put something in quotes, it's a char. For example, age, I could have AGE, I could have age as 10, and this would be an integer. But if I put age equals 10 and I put it in quotes, that would be a string. I'm going to show you guys the difference or why these things might be important later on, but for now, just understand that anything inside quotes makes it a string straight away. So here are some examples. Again, we have integer, 24, double, 10.98, boolean, true or false, chars or string, RonsTechHub. And here's some Python 3 code that shows you the primitive data types. I'm not going to go too much into this. I would say pause the video, have a look at this if you really want to. But when I get to the programming section of this whole course, then I'll be explaining every single thing from start to finish. Next, we have what are data structures? Data structures are essential for storing, organizing, and manipulating data effectively. They are built into most programming languages in some way, shape, or form. And the main four data types we're going to be focusing in Python are lists, tuples, sets, and dictionaries. They all store data in a structured way, but in slightly different ways. For example, a Python list, here's a Python list. You just say numbers equal and you put your square brackets and put your numbers inside. Fruits, you do exactly the same thing. A tuple, you can use exactly the same username, variable name, equal sign, but instead of using square brackets, we use the curly brackets or the curved brackets. And again, we can store the data in exactly the same way. For dictionaries, we use curly brackets. So again, we still store data. We can store similar types of data, but we use the curly brackets instead. And also, if you've noticed, dictionaries have a key and they have a value. So that's a key, that's a value, that's a key, that's a value. And here are the data structures coded for Python 3. Pause the video, have a look at it. We will be covering this at some point as well. So don't worry too much about what they are. Just understand variables can be local or they can be global. I'll explain what this is also described or labeled as the scope of a variable. Local is only usable in that section of the code. So if you have a function and you have a local variable, only that one function can use that local variable. Global can be used anywhere. So we could have a function here at the top, a function here at the bottom, a function down here as well. A global variable would be something that's at the very top that this function can make use of, this function can make use of, and so can this one. Whereas a local variable can only be used inside of the function it was created in. And here are some variable examples. Again, we've seen these before, but we probably haven't looked at them in great detail. So username is the name of the variable. So the variable is always going to be on the left hand side, and this is the thing that describes the type of data we want to have. So for example, here I have a username and I've said it's equal to RonsTechHub. I've got age is the variable name, and this is the value of age, 15. Height is the variable name, 1.56 is the value. Door access is the variable name, and true is the value. Here's another example for a local variable. So I've called my function very creative, right? And the local variable is 10, and I say print local variable, and that's it, done. Now a global variable is created outside of the function and can be used by as many functions as you want. So global variable equals 20, and inside my first function here I say print global variable. Down here I have one that's called modify global variable. So this is going to take the value of that variable and actually change it. And in here it says global variable equals 30, and I go ahead and I print the global variable. arithmetic or math operations, we just like in the real world, I guess we have addition, subtraction, multiplication, division, and remainder division or modulo division. So here we go. So programming is logical, math is logical. The same operators and comparators we use in math, we use in programming. They might look slightly different, but they do exactly the same thing. So the arithmetic operations, here we are. So for addition, it's quite simply print 10 plus 5, sorry about the line. Subtraction, print 10 minus 5. And all that this print thing is doing is putting on screen the answer that we told it to give. Obviously, I've put the answers here just because I don't want to open Python right now. Multiplication, print 10 times 5. Division, print 10 divided by 5. Integer division is print 10 / by 3. What that's going to do is only going to give me the whole number from the division. It's not going to give me 3.3, which is what the answer is. It's going to give me just this part of it, the whole number. And we have remainder division, print 10, that's a percentage sign. 3, that's going to only give me the remainder. So we know that when we divide 10 by 3, we're going to get 3, and then we're going to have 1 as a remainder, because 3 times 3 is equal to 9. We have 1 as a remainder. That's what this kind of division gives you. So this is really good to check if a number is even or odd, because if it does have a remainder, it's probably not going to be even if it's divided by 2. We also have relational operators. They're used in programming to compare two values or expressions. These operators evaluate the relationship between the values and return a Boolean result, true or false. So for example, these are the signs here. So equal to, this checks if value A on the right is exactly equal to value B on the right. If it's a true, then it's equal. This checks if it's not equal. I think I did that twice by accident. This checks if it's greater than or equal to. This checks if it's less than or equal to. I think this was supposed to be greater than, which is supposed to be the opposite of less than. Here are the relational operators again. This is a Python 3 example. So print 5 equals 5. That just says true because 5 is equal to 5. This says print 5 is not equal to 10. That's going to print true. This says print 10 is greater than 5. That's going to print true as well. Print 5 is less than 10. That's also going to be true. This one says print 10 is greater than or equal to 10. That's definitely true as well. Print 5 is less than or equal to 10. That's also true. So what I think I'll do at some point, I might just open up my Python program and just do all of these and show you exactly what would happen in Python when we try to compare things like this. So string comparisons are case sensitive as well. So an uppercase A is not the same as a lowercase a. So that's why print apple lowercase everything equals apple lowercase everything is true. Apple lowercase a is not equal to apple with uppercase A. That's true because they're not equal. The uppercase A and lowercase a have a completely different value when we put that into a program, and we print apple is less than banana. That's true because it doesn't really care. It just checks the order of the alphabet and sees which one comes first, and that's all it cares about. We also have Boolean operators. It's not Boolean, but it's the Boolean operator. These allow us to make decisions in programs. So if I go to the next page, it says and, or, and not. You guys might have seen this before. This is not an extensive list, but these are the 3 that people use the most, and these can be linked directly to logic gates. If you haven't seen logic gates yet, I will introduce them here, but I think there's another unit where we have to go into it a bit more. So the AND gate, this one here, that's what it looks like. The OR gate is that curly one here, and the NOT gate is just gonna do the opposite of what comes in. So I'll explain this quickly because I might as well. The AND gate, these two things, this is input A and input B. Both these things have to be true or have to be present for this one to be true. For example, the switch here has to be on at part A, and the switch at part B must be on as well for the lights to turn on. Pretty simple. So if you think of those vaults you always see in movies where you have the 2 people going up to a door and they both have to put the key in at the same time and turn it at the same time and then press the button at the same time, that's what this is. Now the OR gate is different from the AND gate. Only one of these need to be true. For example, I want to build a smart door, right? Where I can use my fingerprint, I can scan my face, I can use my door card, I can use the NFC from my phone. Any one of these things should be able to open the door. That's what the OR gate does. Only one of them needs to be true for it to work. The NOT gate is the opposite. So let's say we have a switch on here. So the switch is on. Let's draw a switch here. The switch is on. That means that this light is going to be off. If the switch is off here, the light is going to be on. This, just think of this as the opposite gate. This is a very simple, easy one to follow. It's just the opposite of whatever you put into it. So again, the Boolean operator AND returns true if both conditions are true. So if both switches are on at the same time, otherwise it will return a false. The Boolean OR operator returns true if at least one of the conditions is true. It will return false only if both conditions are false. And the Boolean NOT operator reverses the value of a condition. So again, if I turn the switch on, the light actually goes off. If the condition is true, NOT makes it false, and vice versa. So if the input is on, the output output is off. And if the input is off, the output is on. It just flips it around. Again, here are some Boolean operators in Python. Pause it, have a look at it. I will go through this at some point. Next, we have date time. Every single piece of metadata uses date and time. And metadata, we probably haven't seen this yet. Metadata is simply data about data. For example, I create this PowerPoint on my computer, right? It saves the date I created it, the time I created it, who created it, on what operating system, the type of file it is. It saves a lot of data about the data. That's what metadata is. But date time is one of the most fundamental things for computer science nowadays, because everything must have a date and time was created or edited or deleted. Every single database uses date and time. It is so important that it has its own category, which makes it easier to track and manipulate. So again, in Python 3, this is how we get date and time. This is one example of how we can do it. Next time, we're going to be looking at built-in functions. I'm going to try and stick as closely to Python 3 as possible. Stay tuned.